Welcome back. So in the last class, I included in my lecture technical specifications sheet which is provided by the manufacturer for a given robot. So essentially we covered some of the specific parameters which are necessary to define the performance of a robot, how my robot is going to perform, what is the capacity of my robot. If at all I desire to use a robot for a particular application, what are the parameters that I should look for? For example, I discussed on payload, I discussed on mounting flange dimensions, repeatability, joint angle limits, working envelope, etc. So apart from that, I also discussed mandatory requirement of ISO 9946, which also states some of these parameters which are mandatory to be included in any specification sheet to be called as an industrial robot. If the data sheet is for industrial robot and they want their robot to qualify to be compared against any other industrial robots which are available, they should be using ISO 9946 directives. Okay, so in today's class we'll extend further on this and we'll see how industrial robots are classified. Okay, so let us start. Okay, in today's lecture I'll be covering mostly existing internationally approved classifications, JIRA and AFR, and classifications based on power source, classification based on workspace geometry, classification based on degrees of freedom, classification based on kinematic structure, movement, and different types of application. You can further classify a given robot. Okay, so yes, classification by Japanese Industrial Robot Association, JIRA, has some special way of classifying industrial robots. That is one of the pioneer in classifying, giving definitions for classifying industrial robot. It says class 1, it has divided classes to 6 different classes. One of them is manual handling robot, that is class 1, a device with multiple degrees of freedom that is actuated by an operator. It is purely a manual robot. Okay, there is no automation. It may be not even including an electronics or sometimes not even including any sort of computational software behind. Okay, so that is class 1 of a type of robot. Class 2 says it is a fixed sequence robot, a device that performs the stages of a task according to predetermined unchanging method and is hard to modify. It is very much like a CNC machine, but the way it differs from a CNC machine is basically the type of mechanism it is and maybe the task that it can perform. Okay, so class 3 says a variable sequence robot. In this one, actually, device that performs successive stages of a task according to predetermined and unchanging method and can be easily reprogrammed. So here comes the picture of some programming aspect of a robot, and now it fits well into our definition of the robot also. Okay, so as we have defined earlier in our first class. Okay, so now playback robot, human operator performs the task manually by leading the robot to a place which records the motion for later playback. So teach and repeat functionality is now added to this type of robot. Robot repeats the same motion according to the recorded information. Okay, in order to do this also you need to have some sort of program which can store the data and they can reproduce the same data. They have some sort of playback sequence which it can regenerate. Okay, and then the class 5 is a numerically controlled robot. The operator supplies the robot with the movement program rather than teaching the task manually. Okay, so this is excluding the other classes like playback robot class 4. It is not including in it. And this one is basically rather than teaching, it can be done manually. Means you can program for certain type of motion, and robot can simply repeat what is being programmed. Let's say I have programmed my robot to follow a profile, okay, and it will simply follow that profile, okay, maybe for n number of times, okay. And the sixth one is actually the most intelligent one. You see, it is the most intelligent robot. Okay, this says the robot which is with the means to understand its environment and the ability to successfully complete a task despite changes in the surrounding condition under which it is to be performed. Okay, so in this case, now the picture of complete intelligent robot has come in. Okay, it can not just do the task which is for which it is programmed for. Okay, it can understand the environment, it can understand the any changes, and it is ruggedized to work despite of any surrounding changes. Okay, so that is class 6 classes of these robots. So as I told, the first two definition, at least the manual handling robot and fixed sequence robot, it doesn't fit into standard definition of industrial robot, okay, or in general any robot. Okay, so Robotics Institute of America, RIA, only considers the classes 3 to 6 to be robots. Okay, however, they are being classified as robot, but they are not actually robot, it says. Okay, so again, second very important classification was given by AFR, that is French Association for Industrial Robotics. Okay, this has defined 4 different types of robot. Okay, it includes, first one includes the handling device with a manual control to telerobotics. Telerobotics means an operator is sitting somewhere in the remote and he is able to control the robot remotely, okay, like a master-slave system maybe. So this is also similar to the one which was defined in class 1 of JIRA. Okay, now the type B, automatic handling devices with predetermined cycles, just like classes 2 to 4 of earlier definition of JIRA, automatic handling devices with predetermined cycles. Okay, and then type C includes the programming aspect, programming servo controlled motor with servo controls robots with continuous or point to point trajectory. So now it can be programmed for going from a point to a different point in a given trajectory also. This is basically the class 5 of JIRA. Type D is basically the intelligent robot. It is programmable also. Servo controlled robots equipped with sensing systems. So now it is sensitive to the environment. It may be doing its job based on the environment changes, or it is maybe programmed to be ruggedized against those environment changes, and the capable of adapting to changes in the surrounding conditions. Okay, this is as good as having class 6 definition as it was there. Okay, so type A is basically a teleoperation robot, master-slave kind of thing, or a sequencing robots is given by type B. Type C is a CNC robot. Again, it is not like a CNC machine owing to the type of mechanism it is made up of and the tasks which it can handle. Type D is intelligent robot. Okay, so these are some of the standard internationally accepted classifications which are there. Now we'll look upon some different ways of classifying industrial robots. Okay, moving ahead, based on the power source, how we can classify a robot. As in ISO 9946, this is a mandatory requirement, as I have said. So a robot can be classified with electrical actuators, electrical motors with which it is made up of, hydraulic actuators, it can be pneumatic actuator, or it can be powered by some non-conventional sources. We'll see that now. So yes, most of the industrial robots are electrical in nature. As you know, electricity is abundant. You can find it anywhere. It is readily available. It can be of two types, AC or a DC kind of electrical power which is available. So we'll look upon various features of AC and DC kind of thing. So DC motor normally they can provide higher torque, mostly higher starting torque, which is very helpful to make compact robots. And as because DC motor normally has carbon brushes within, we'll see very much in detail the construction of DC motor, AC motor, stepper and various kind of motors in our next module. However, for the completeness, you should understand, yes, it is made up of carbon brushes. With our background, we know it most of the time. So carbon brushes goes into it, armature with coils, which has some commutator which is there. So few additional parts are there. So number of parts are more, so maintenance is more in this case. Okay, BLDC motor, that is brushless DC motor, it is lighter. It bears almost a similar type of features which a standard DC motor has. However, the drivers are little bit complicated. It doesn't have brushes. It doesn't have brushes or commutator that makes it even more compact. And because it has less parts, no wearing off of brushes can occur. It has more life as well. It is a AC or DC motor. Normally it has geared gearboxes which are attached to enhance the torque rating of the motor or sometimes to reduce the speed of the motor. So you can go for BLDC motor type of robot or a brush geared motor type of or stepper motor. So these are few of DC motor kind. They are used in mobile robots. Why? Because you cannot have a AC motor on a mobile platform. It is very difficult to make AC portable, right? You need to have a generator or an alternator on board your robot. So that doesn't fit in on an aerial vehicle, at least, where you need your robot to be very lightweight, right? It has to be agile so that you can quickly maneuver in the air. So just like a quad rotor or a drone you call it. So for the similar reason, even underwater robots, they have a DC powered source. It can carry battery on board, so that has a stored energy. AC servo motors are normally suited for large capacity industrial robots because they are normally grouted to the ground, and they are in the industry where you have huge power supplies which are readily available again. And AC motors are again, they are very compact, so that is the reason it is used. Mostly with synchronous AC servo motor. Normally AC motors doesn't go all alone. There are many attachments to it that makes it fully controllable. One of them is having a feedback. Servo means a feedback. So AC synchronous motor, which are normally run by variable frequency drives, those kind of motors with a gearbox and many other attachments like encoder behind or a optical encoder or a magnetic encoder, some sort of position and velocity feedback devices are there. We'll look upon them very much in detail while we'll be discussing actuators. Okay. So another very important classification part that you can see here is a hydraulic motor. So few of the actuators can be hydraulic in nature, like over here you see to the figure you see, this is usually a very large capacity robot, very large capacity robot, because hydraulic power packs is very difficult to fit in on board a robot, or they are very hugely expensive. Although hydraulic actuators can provide huge amount of power in a compact region of the robot, so they are mostly used for large capacity robot. Okay, so that goes here in this. This is a rescue robot which is T5, which is known as manufactured by Thamsuk, a company which makes a rescue robot of various kinds. So this is one of them. You see, it has linear actuators which are here, which is hydraulic in nature, which is here, and which is here. So these are few places which you can at least see here. So this is just like an earth moving vehicle, like bulldozers or JCBs that you find all around while construction works are going on. It may be one of them which is automated through some remotely teleoperated device. So the things which you see down below is basically a suitcase kind of thing which a robot operator can take it on the field, where they have joystick for both the arms that you see here. This robot has two arms, each one of them can be controlled using two different joysticks, and the user can see a live feedback. So you see this is the scale of this robot, where it can do excavation task. If at all there are some earthquake which has happened, so it can remove the debris, rescue people, and those kind of things can be done with this kind of robot. So you see it is very, very useful. However, it fits into a very different category of robot which is run by hydraulic actuators. Okay, and then everything comes at a cost. So even this one, because hydraulic power, to generate hydraulic power, it has to have a hydraulic power pack which keeps motor running continuously, that keeps on developing the pressure for the actuators. So it creates a lot of noise, and it uses oil. So obviously there are some leaks which can happen, and because it is oil, fire hazard is there. It requires some sort of maintenance also. You see, let me just move here. Yes, maintenance is there because it has more number of parts. Obviously it needs a good amount of maintenance to be done, and an accumulated thing because of maintenance is manpower requirement, and so on and so forth, right? So that is a hydraulic actuator driven robots. And then finally is the last one, which is a pneumatic kind, where it's like a soft cushion. It is just like a pump. If you have seen cycle pump, it is very much similar to those kind of actuator, where instead of getting air out of it, you push in air and your actuator will go out, right? If you pull out the air, it will come back, right? So that is the way it is driven. So this kind of robots, yes, they can develop very high speed in a very short amount of time, and it can be very, very compact because no actuators are there. Actuator is somewhere else, that is the compressed air bottle which is kept somewhere else. And you see this kind of robot can also work, but only thing is you have to be a bit careful because air is compressible in nature. So what happens, because of compressibility, it loses some sort of precision, and over increase in some sort of temperature, what can happen, this air can expand, no? So that will create some sort of drift, and those are the related issues with this kind of robot. So yes, pneumatic robots are there. Okay. Okay, and there are some non-conventional sources also, like nuclear submarines. They use a kind of teleoperated robots sometimes to maintain the outer periphery of the hull of your vehicle, right? And sometimes in the space exploration also you have robots which go out into the space and do some maintenance job to your vehicle. Solar panels of the space robots, they are normally run by solar power. Although all of these, they look like non-conventional robots which run with different kind of electrical power source, but all of them are electrically actuated robots. Why? Because essentially all the robots are run by motors. Motors are driving power out of nuclear source or solar panels or some kind of other non-conventional energy sources. Energy is something which is different, otherwise essentially they are all electrical actuators. Okay, so this is one of the broad classification which is there. And you see, based on the workspace geometry, that also is an requirement of ISO 9946 that says to include this in the technical specification of the robot. That is as a name they call it mechanical structure of the robot, right? So it can go like this. A few of them will go very much detail of for each one of them. Now let us begin with a Cartesian robot, which is PPP type. What does it mean? It has three prismatic actuators. If you see carefully, this robot, this is the arm, which has an actuator that can move in this direction, another one can go in this vertical direction, third one can move in this direction. Okay, so essentially it has x-axis, right? It has a y-axis, it can also move along z-axis. So all the three axes, this arm can go. So effectively it can go anywhere in space which is covered by a rectangular volume. Okay, so they are very good for heavy load in the industry. They are simple, easy to understand, because you can judge, yes, if I am going 2 meters along x, it is 2 meters along x, nothing else, right? So that is very easy to understand, sometimes easy to program because of this reason also. Okay, so another very important kind of robot is a cylindrical robot. Only the first axis has changed, rest two are same. So yes, you can change the height of your arm, right? You can change the radius of the cylinder by changing the extension of your arm, and the first axis, instead of having something like this time it can rotate. Okay, this time it can rotate. I'll show you the video also in the next slide also. Okay, so this is essentially covering a cylindrical workspace denoted as RPP, revolute, prismatic. Okay, prismatic actuators are linear in nature, they can move back and forth, right? Whereas revolute axes are just like motors which can just rotate. Okay, so it has two kinds of motion. First is revolute, this is revolute, this is prismatic, got it? So yes, and the third one is a kind of robot which is RRP, revolute prismatic. So first axis is a rotary one, second axis is also a rotary one, both the axes are orthogonal to each other, and then you have an arm which can extend. So this basically will change the radius of the sphere which it can cover. Okay, so workspace is something like a sphere. Okay, so two revolute axis is there, one prismatic. Range, it has a very large range, but they are very uncommon in the industry. The last but not the least one, that is the articulated arm robot, which you have seen so far in our application video also, where you have first axis which goes like this, you have multiple axes and one after the other, just like our arm, they are fitted. So you have multiple axes, you have a link, you have a joint, you have a link, you have a joint, you have a link, another joint. It forms a serial chain effectively. So that is what is articulated arm all about. So these are four major kinds of robots which can be classified as mechanical structure classification, right? The first one, again coming back to the Cartesian robot, it is known as a gantry robot also. It has a rectangular work volume. You saw it just here, this one. Okay, you saw it just here. Okay, so this is the one. So it has these robots have three linear joints that position the end effector, which are usually followed by an additionally revolute jointed joint for controlling the orientation. Okay, it can go to any position x, y and z, so it can effectively go to any position in x, y, z in a Cartesian volume. Okay, but yes, now that you have reached there you have to do something. So in order to do something, sometimes you need to orient. Okay, you need to orient. So I'll just show you, start one of the video here. You just look carefully this robot what it does. So it has a end effector which can orient so as to make itself always normal to the surface where it is working upon. Let's say it is doing some spot welding operation, it is doing some laser burning operation, applying a glue or anything which is very similar. So you see, last one is just an orientation tool which is attached, which is to orient. Okay? Otherwise it is just a battery robot. So this is how it is operating. They are very common to do any sort of inspection, CMM machining, laser cutting, right? Pick and place tasks, sometimes loaders and all. There are many makers, I have just listed them here, which makes it. The one which you saw here is of KUKA, but other companies are also making it. Few of them are Bosch Rexroth, right? Montec, Promot, IAI, Fibro and so on. Yes, these are few manufacturers, okay. So yes. So now this is the cylindrical robot. This looks like a physical robot, looks like this. That was a cartoon of it, like simple the line diagram of a similar robot that I have shown you. So it is a RPP robot. In short form it can also be called as R2P. So 2 times P. Okay, these robots have a rotary joint and have 2 linear joints that position the end effector, and usually followed again by additional revolute joint for controlling the orientation. Again, a short video will suffice it, right? You just see how it works. First axis is the rotary one, second one is taking it up and down, the third one is the arm itself that can extend, go back and forth so as to increase the radius or decrease the radius, right? So essentially it has a cylindrical workspace, but because the radius cannot go to a 0 value, so that is a hollow cylinder. Cylindrical workspace. This is how it works. So it is very few makers are there, Seco, Hudson, ST Robotics, and very limited operation are there. So it is used primarily in the hotel industry. Tool loaders, pick and place tasks can be done because it has just 3+1 degrees of freedom. So it is very inexpensive to be used for those reasons. Got it? So yes, this is the oldest one. This is already the robot which was the first robot which was there in industrial category. Okay, so this is a spherical robot, 2RP. These robots have 2 rotary joints and 1 prismatic joint that position the end effector, and may have again an additional revolute joint for controlling the orientation. Makers are Unimate, Kawasaki. Okay, this is already obsolete. You don't find this type of robots anymore in the industry. Applications are limited, lack of vertical axis motion. There is no axis which can make it go vertically up and down. Okay, so that is something which is this type of robot is lacking. Used as a tool loader and a specific pick and place task.
Industrial technology is now heralding the age of manless production. Numerous tests are being carried out on Kawasaki Unimate, a multi-purpose industrial robot.
So yes, these are a few robots of its kind, yes. And finally the articulated arm robot, 6R, 6 revolute joint, or in combination with prismatic joint. So you can have revolute, prismatic revolute. So that could be there, but most of the time in industry I have seen all revolute jointed robots are there. Okay, these are serial chained robots and normally have 6 rotary or in combination with prismatic joint that can position the end effector as well as it can orient the end effector in space. Okay, major makers are Yaskawa, Fanuc, ABB, KUKA and many others which are there. Okay, applications, almost all industrial jobs that includes pick and place, surface finishing, welding, painting, collaborative task, okay, grinding, polishing, assembly task, all these can be done with this kind of robot. So this is how it looks like. You need no video for this because in the first class I have shown you plenty of these robots, right? So we'll be working most of the time on this. So this is one broad classification again which is based on the degrees of freedom, or you may call it a number of axes. In case of serial chain industrial robot, both are almost the same. Because very few times you see degrees of freedom is not matching with your number of axes. We'll discuss very much in detail while we'll be discussing kinematics of the robot. So yes, it can be a planar robot, simply a planar robot, the way your engineering drafter is. How many degrees of freedom you just should think now. it can go anywhere on your board, no? Engineering board, it can go anywhere. So it is XY position it can attain. The third one you can do, you have a angle, a set square kind of thing which can orient over there, no? Once you reach there, you can change the angle. So that was the third degree of freedom which your engineering drafter can attain. So that is a planar robot. It can be 2 degrees if you just want to reach there, or otherwise you may have an additional rotary revolute joint over there. Okay, spatial robot, mostly they are of 3 degrees of freedom, pure translating or combination of translating and rotating joints. Okay, 6 degrees of freedom can be 3 translations. See, minimum 3 degrees of freedom is required to make your robot go anywhere in space, x, y, z. Okay, and then you need additional 3 degrees of freedom to orient your robot. You got it? So this is what is the requirement of having a 6 degrees of freedom. So that is the requirement, and then you may have a redundant robot which can have more degrees of freedom. Essentially, in space once you go, you can have 6 degrees of freedom maximum, right? You can either move in all the 3 directions or you can orient in all the 3 directions. So maximum what you can obtain is 6, but input side number of joints can be more than 6. In that case it is redundant robot. There are few robots which are there which has infinite number of solutions just to go to a place, right? So that is the advantage of having such robots. They are redundant robots. We'll discuss on them also. So there are few special kind of robot which is having just 4 degrees or 5 degrees of freedom. You don't need to have all the degrees of freedom for any kind of job. You may be just needing, like for your engineering drafter, you just needed 2 degrees of freedom. You don't want 3 degrees of freedom. You know you have to be on that plane all the time. So you don't want to have more than 4 or 5 degrees of freedom, right? So that is the need for that. So yes, for limited degrees of freedom, robots are for special purposes. Like for electronics industry, when you just need to pick and place vertically IC or circuit components and you just have to place it on board, SCARA is quite good enough, right? So that is there. So this is one of them. Based on the kinematic structure, you can further classify the robot. One of them is open loop serial chain robot. Serial chains are nothing, as I have just told. It is just like your arm. You have a link, you have a joint, again you link, another joint, you have a link and a joint, so on and so forth. That makes, and finally it terminates with a flange. Flange can have a gripper or any tool which robot should have to perform a particular kind of job. Got it? So that is a serial robot. And you can have a closed loop kind of robot which is a parallel robot. Over here what you see, it has multiple actuators, okay, and there is a platform. So this is the platform, okay, this is the platform which can move, and then you have actuator which is over here, you have an actuator which is here, you have an actuator which is here. So all the levers you can move, and this finally, this can go up and down, this can move, and that makes this platform go anywhere along X, Y or Z directions. Okay, so this is a parallel robot when all the 3 are moving simultaneously. I'll show this in operation while I'll be discussing serial and parallel robots in one of the lecture, just in this module. Okay, so this is a parallel robot. Okay, and this is a kind of a hybrid or a tree type robot system when you have combination of all these, right? So as long as this robot is on floor, this is a Boston handle, if you have seen the video of this. So it has wheels also, wheels can maneuver at very high speed on the floor, right? If the surface is flat, so it can move at very high speed. So it takes the advantage of that. As long as both the legs, so it can apply brakes to both the wheels. Now it becomes 2-legged robot. Got it? So that is what is making it an hybrid robot. It is a wheeled robot as well as it is a legged robot. And as long as both the legs are on floor, you see it is like this. So this is your floor. So this is your torso where your joints are there. So this is a body, and then you see what is it? It is two different serial robots which is connecting this platform. So effectively what is this? This is a kind of parallel robot as long as both the legs are on the floor. And then you have two serial chain robot which are open robot, just like your arm, and it looks like a tree, you know. You have a trunk and then you have branches which can move in air, right? So that is the reason it is named like hybrid or a tree type system. Okay, so this is based on the kinematic structure. You can further classify the robot to a open chain or a closed chain. Each one of them has its own advantage and disadvantage. Two of these we'll be discussing very much in detail, at least a serial and a parallel robot, in next lecture. And tree type system is beyond the scope of this syllabus, but still you may find plenty good amount of videos for this kind of robots. So, and then there is robot which fits into your imagination of having a robot in your home, which looks very much like human. You see, it can do all kinds of jobs normally, can be programmed, what a normal human can do. Right, so it can take care of a child, it can look after some elderly people, okay, it can serve you dinner, right? So it can be programmed for various things. It has various type of sensors, it has arms which are very much similar to your arm, right? Possibly it can be programmed for anything, but actually it is not, right? So there are facts always. So yes, so these are some kind. So all together it goes like this. So this is based on the kinematic structure of the robot. Okay, and then you have fixed installation robot based on the movement. Based on the movement, I am classifying. Okay, so because these two robots fit into the one of them is a serial robot, one of them is a parallel robot. Got it? So they already fit into one of the category, but this category, when we start classifying based on the movement, these two robots are fixed base robot. It is mounted on floor. This is hanging from the ceiling. Okay, so both of them are fixed. The robot itself is not moving, right? So that is why that is there. So yes, and then you have mobile robots which may have wheels. The one which is here is a Mars rover, right? It has wheels, right? And even this one, it has wheels. This is Kuka Omni robot, which has multiple Omni wheels, which makes it move along XY plane anywhere, right? And this is again a legged robot with a quadruped normally, and it has an arm also. So it is a serial chain. And it has legs, so it has a pedal robot also, you can say a quadruped. Okay, so it is quadruped robot, it has 4 legs. So yes, all these are mobile robots. They are not fixed to any place and they can move anywhere in your location, right? So yes, so another big classification is swimming robots. It can swim on the surface or it can go inside the water. Some exploration can be done. You might have seen in National Geographic or Discovery channels this kind of robot. They are mostly teleoperated robot which are connected from a base which is floating on the top, and that is ship. From the ship it is connected using tethered cable like this. Okay, cable is connecting and then it is remotely operated from the top. So it may not fit 100% like a robot. It hardly does few things only using autonomous mode. Otherwise mostly it is a teleoperated robot. Okay, so yes, but yes, it is capable of going into the inside the water. So yes, it is it can move inside the water, so it fits into this particular classification. Okay, so yes, another big one is aerial and flying robots. You must have seen nowadays in parties and all, this type of cameras are shooting you. So it has a camera which is here, right? It can fly, it can maneuver, right? It can be floating anywhere in space, XYZ, in space, and it can carry some payload like camera, like some sensors. Okay, so it can nowadays it has potential to be used like a drone delivery of some sort of courier, right, or food packets. So yes, it is used for military surveillance and many other things. So this is your aerial robot which fly, right? So yes. So now based on the movement you saw all these kinds of, there are many other classifications which can also be formed. One huge one is based on the application. ISO 9946 also says your robot manual, your data sheet should mention the application where for which this robot is designed. So yes, based on the application, you also can classify your robot kind. Yes, it can be industrial, it can be domestic. If it is an industrial robot, it can be painting robot, it can be arc welding robot, spot welding robot. We'll talk about mostly industrial robots from now on. Okay. So because you find not just all these kinds of robot in the industry, so there are few broad categories of robots that you see in the industry are articulated arm robot and parallel robot. So the majority of applications are of this that uses these kinds of robot. One of them is this one, that is selective compliance articulated robot arm, that is SCARA, 4 degrees of freedom robot. You see it has first axis which is like this, second axis which is like this, rotary, and the third one, this has 2 rotary as well as it can go up and down. So if it can take your robot anywhere in XYZ and it can rotate at that point of location where it can reach. Okay, it is used mostly in the electronic industry for any pick and place task. This is a 4 degree of freedom robot, but still it suffices that particular job. Why? You know, you don't need to roll or you don't need a pitch when you are doing pick and place operation. You don't need to roll or you don't need to pitch. So you just have to go vertically downwards and you have to go vertically upward and put it somewhere else. Okay. So that is the reason it is used mostly, and they are very, very fast. They are very, very fast. All the actuators, most of the actuators are sitting here. So that is the reason, because actuators are one of the heaviest part of the robot. If it is non-moving along with the arm, so that can be very, very fast. So it is driven by belts, if you can see. Yes, it has belts, so it comes here. Finally this also has a belt. So these 2 axes are driven from a same location, that is here, and everything is because it has less degrees of freedom, less number of motors, so it is very, very light and it is very, very fast. Again, big classification that you know is a delta kind of robot that I have shown earlier for Fanuc. Yes, so this is a 3DOF delta, but it can be a 4 degree of freedom if you attach a gripper that can do rotation in its axis. Okay, you can go to any XYZ place and then you can orient it vertically in the vertical axis. You can rotate. So these again are very, very fast. It has all the actuators which are fitted here. It has 3 actuators commonly known as a delta robot. They again are very, very fast because the links are very, very light. Okay, they are sometimes made up of composite fibers and those kind of stuff. So they are extremely fast. So they are used mostly in food and beverage and agro industries. Okay. Yes, that's all for today in this class. So what you have seen now, you are now able to classify a robot based on type of architecture it is, type of degrees of freedom it has, the way it is powered. So all those stuff we have discussed today, and few of them were a requirement of ISO 9946 to be mentioned in the industrial data sheet. Few of them are not, like hybrid robot need not to be, there is no specific rules for many such robots, at least for anthropomorphic robot and all. So what you should mention, what you should not, is not a prerequisite, but yes, you have learned that now. And in the next class we'll discuss mostly upon serial and parallel robot, which are again two broad classification. The way you saw in this was serial, this is parallel. We'll talk further on this kind of robot, okay, in the next lecture. That's all. Thanks a lot.